In this video, we look at finding percentiles of a distribution for a continuous random variable. Now, let x be a continuous random variable with CDF denoted by cap f, and let pi sub p denote a level p percentile of the distribution of the continuous random variable x. Now, because pi sub p is a level p percentile of the distribution of x, remember that it's got to satisfy two conditions. It's got to satisfy this condition here, which was actually the second condition that we listed in the previous lecture video. All right, and there's a reason why I've reversed the order, but it's got to satisfy both these conditions. So the probability that x is less than or equal to pi sub p must be greater than or equal to p, and the probability that x is strictly less than less than pi sub p must be less than or equal to p. Now, because x is a continuous random variable, remember that we can fiddle with the inequalities and not change the probability. So in particular, I can change the non-strict inequality less than or equal to pi sub p to the strict inequality strictly less than pi sub p and not change the probability. So the probability of these two events are the same because x is a continuous random variable. Now, because of that, I can convert. So if we substitute this probability, which is right here, if I could get it to highlight correctly, but right here you see where I'm pointing. Okay, this is equal to the probability that x is less than or equal to pi sub p. And so what this implies is that based on this inequality, the probability that x is less than or equal to pi sub p, by virtue of that being equal to this probability must be less than or equal to p. And so from that we get this inequality, the probability that x is less than or equal to pi sub p is less than or equal to p. And then from the first result we had up here, the first inequality, it must be the case that the probability that x is less than or equal to pi sub p is greater than or equal to p. Now notice what we have here. We have this probability in both places, here and here. So this is a real number that is less than or equal to p and greater than or equal to p at the same time. So that implies that this probability must be exactly equal to p, right? In order for a number to be less than or equal to a given value and greater than or equal to that value at the same time, it must be equal to that value. Now, this probability, you'll recognize this as being of the form that is given by the CDF of the distribution. All right? So therefore, pi sub p is a level p percentile of the distribution of a continuous random variable x if and only if this equation is true. The CDF evaluated at that level p percentile, pi sub p, is equal to p. So in other words, the value in the subscript here of pi, it's going to be the same value. That's going to be the value that is taken on by the CDF when we evaluate the CDF at this particular level of percentile. And so to find a level p percentile of the distribution of a continuous random variable with CDF cap f, it suffices to solve this equation for pi sub p. In other words, we set up this equation, the CDF evaluated at the desired percentile, or evaluated at the percentile, that is equal to the level that we're wanting, p, and then we solve that for the unknown, which is pi sub p. So let's look at an example. This is example 37. And so let x be a continuous random variable with PDF of the following form. And so the PDF is given by c times x for x between 0 and 1, and the PDF is 0 otherwise. And so we've seen this PDF before. We know that the constant c has got to be equal to 2 in order for this to be a valid PDF. And so for this distribution, we're going to find the set of all values satisfying the definition of being a median of the distribution. And then we're going to find the set of all values satisfying the definition of being a 25th percentile of the distribution. Now recall that the CDF of x for this distribution is given by this piecewise defined function here. Cap f, the CDF, is equal to 0 if the argument at which we're evaluating at x is less than or equal to 0. It's equal to x squared for values of x that are between 0 and 1, and it's equal to 1 for values of x that are greater than or equal to 1. Now, based on the argument that we just gave on the previous couple slides, since x is a continuous random variable, to find a median of the distribution, and again the median would be denoted by pi sub 0.5, it suffices to solve the equation given here. F evaluated at the unknown value of the median being equal to 0.5. All right, and so putting the 0.5 here on the left-hand side of the equation, that has got to be equal to f evaluated at pi sub 0.5 in order for pi sub 0.5 to be a median. Now, we know that in order to be a median, pi sub 0.5 has got to be between 0 and 1. It's got to be in this interval here. And so the expression for the CDF at such a point would be the square of the argument at which we are evaluating the CDF. And so this would have to be pi sub 0.5 squared. And so to find the median, all we have to do is solve this equation for the unknown, which is pi sub 0.5. Well, if we take the square root of this equation, we'll get two potential values for pi sub 0.5, either the square root of 0.5 or negative of the square root of 0.5. Now, the negative value cannot be the median because the space of the sample space of x is the interval from 0 to 1. So a negative value could not be, it would be impossible for a negative value to be the median of this distribution. And so it must be then that the median of the distribution, pi sub 0.5, is equal to the square root of 0.5, or equivalently, the square root of 1/2. And so here I have graphed the CDF of the distribution of x. You've seen this before in a previous example. And then what I did was I drew a horizontal line, graphed a horizontal line at a height of 0.5, which is the desired level of the percentile. And then the point at which that horizontal line intersects the CDF, that is going to be the point that corresponds to, in this case, the median of the distribution. Now, what I've also done is I've drawn a vertical line at the square root of 1/2, all right, which you'll remember to be a little bit larger than 0.7. And so you can see that this vertical line intersects the horizontal line and the graph of the CDF in exactly the right spot. So this shows graphically that we've found the right solution, the right value for the median. Now, suppose that we hadn't gone through that argument, gone through that calculation. We could still graph the CDF, draw a horizontal line at the desired percentile level, in this case 0.5, and we could get a pretty doggone close approximation to the median of that distribution by just hand drawing a vertical line through the point of intersection of the level and the CDF. Okay, now let's find a 25th percentile of the distribution. So to do this, all we have to do, if we can, is to solve this equation for pi sub 0.25. Now, in the same ways as we, for the same reason we had in the previous part of this example, the desired or the equation we've got to solve is this equation here. Pi sub 0.25 squared is equal to 0.25 or 1/4. Okay, so we can take the square root of both sides and we get two solutions then, two potential solutions for the 25th percentile pi sub 0.25. Either the square root of 0.25 or negative square root of 0.25. And again, since the sample space of this random variable is the unit interval from 0 to 1, it would be impossible for a negative value to be the 25th percentile of this distribution. So even though mathematically this is a potential solution, it's not a real solution in this case because of the nature of the problem. So the only 25th percentile of this distribution is the square root of 1/4, which is 1/2. All right, and so here I have a similar graph. I've graphed the CDF of the distribution of x, and then I've graphed a horizontal line at the desired level of percentile we're looking for, 0.25, and then the point at which that horizontal line intersects the CDF, if we drop a vertical down, that will intersect the point which in this case corresponds to be the 25th percentile of the distribution. Now I've also drawn a vertical line through the point 1/2, and you can see again that the two lines, the horizontal and the vertical line, and the CDF curve all intersect at the same point, showing that I've done my analytical calculation correctly. So to summarize, finding the set of all values satisfying the definition of being a median of the distribution, there's only one, the square root of 1/2, and the only 25th percentile of the distribution is 1/2. Now let's look at example 38. Let x be a continuous random variable with PDF of the following form. So for values of x between 0 and 1, the expression for the PDF is 4 times x minus 4x cubed, and the PDF is 0 for any other value of x. And so again, what we're going to do is find the set of all values satisfying the definition of being a median of the distribution of x, and also find the set of all values satisfying the definition of being a 25th percentile of the distribution of x. Now recall that we've seen this distribution before. In fact, when we first saw it, we were given the CDF, and the CDF is reproduced here. All right, and so for the values of x less than or equal to 0, the CDF is equal to 0. For values of x that are greater than or equal to 1, the CDF evaluates to 1. And then for values of x between 0 and 1, the expression for the CDF is 2 times x squared minus x to the 4th. Now, again, since x is a continuous random variable, in order to find a median of the distribution of x, it suffices to solve this equation right here for pi sub 0.5. Okay, so f evaluated at pi sub 0.5 equal to 0.5 is the equation that we need to solve for pi sub 0.5 in order to find that median. All right, now we know that the median is going to have to be on the interval from 0 to 1, and so when we plug pi sub 0.5 into as an argument to the CDF, then we know that the expression is going to have to be 2 times the square of that pi sub 0.5 minus pi sub 0.5 to the 4th power. And so that is what we have right here. And we set that equal to 0.5 or 1/2, and then we solve that for pi sub 0.5. Now, this is a quartic equation, and in order to solve this, let's use the following analytical device. Let's let y be equal to the square of pi sub 0.5. And so then this quantity right here becomes y, and this quantity here becomes y squared. And so this equation, re-expressed in terms of y, is equal to 0.5, or 1/2 equal to 2 times y minus y squared. This is a quadratic equation in y, and it's much, much easier to solve. Now, applying the quadratic formula to this equation gives us two possible solutions. Y equal to 1 minus the square root of 1/2, and y equal to 1 plus the square root of 1/2. Now, we know, because the sample space of this distribution is the unit interval from 0 to 1, we know that the median, pi sub 0.5, must be between 0 and 1. It cannot be greater than 1. Okay, and since since y is the square of such a value, it follows that y has got to be between 0 and 1 as well. And so what that does is it precludes this potential solution as being an actual solution. And so it must be the case that this is the only solution that will work for us. And so what that means then is that the square of the median, the square of pi sub 0.5, which we've denoted by y, must be equal to 1 minus the square root of 1/2. Now, again, this is a quadratic equation, and this is easier to solve because this is the only place where pi sub p shows up. And so we can take the square root of this equation, and when we do that, we once again get two potential solutions. All right, the first one being pi sub 0.5 being equal to the square root of 1 minus the square root of 1/2, and the second potential solution as being pi sub 0.5 equal to the negative square root of 1 minus the square root of 1/2. Now, again, because we know that the median of the distribution has got to be between 0 and 1, that precludes this second potential solution as being an actual solution. And so the only actual solution we have, the only workable solution for this situation, is given here. So we know that then the median of this distribution has got to be equal to the square root of 1 minus the square root of 1/2. And so here I've got the graph to illustrate this, graphically demonstrate this. I've got the CDF of x graphed here, and I've drawn a horizontal line at the appropriate level, the desired level of the percentile we're looking for, in this case the 0.5 level, or we could also call it the 50% level. And then I've drawn a vertical line at the solution that we found, the square root of 1 minus the square root of 1/2. Okay, and so then we see here that the horizontal line, the vertical line, and the CDF all intersect at that same point, and so we know that we found the right solution. Now again, suppose we hadn't gone through that analytical calculation to find the value of the median. Well, what we could have done is approximated the value of the median by graphing the CDF, drawing a horizontal line at 0.5, and then drawing a vertical line through the point of intersection of the horizontal line and the CDF. And that would give us, it would allow us to graphically approximate the actual value of that median. Okay, now we're going to find the 25th, or find a 25th percentile of the distribution. And so to do that, all we need to do, if we can, is solve this equation here for pi sub 0.25. And so again, we have this quartic equation that we have to satisfy, 0.25 being equal to 2 times the square of the desired percentile, the 25th percentile, minus the 25th percentile raised to the 4th power. And so again, we're going to use the same trick. We're going to let y denote the squared value of this 25th percentile, pi sub 0.25. So when we do that, we can re-express this equation as a as a quadratic equation, which we can then apply the quadratic formula to find values of y that would satisfy this equation. So because it's quadratic, there are 2 potential values, 2 potential solutions. There are 2 mathematical solutions, and it's going to turn out again that only one of them is going to work for us in this context. So the 2 potential solutions are y being equal to 1 minus the square root of 3 over 2, and I've got to say that so that it makes sense. The annotation probably, it may not, well, if you're reading it, it may not be clear what I'm saying, but you can see the notation there. So that's one of the potential solutions, and then the second solution is y being equal to 1 plus the square root of 3 over 2. And again, since we know that this 25th percentile has got to be between 0 and 1, we know that the square of that value has got to be between 0 and 1 as well. And so that would, again, preclude this potential solution, or this second mathematical solution, from being an actual solution in this situation. And so we know that the square of pi sub 0.25 has got to be equal to 1 minus the square root of 3 over 2. So then we can take the square root of that, and then we get, again, 2 mathematical solutions, 2 potential solutions to our problem. But again, it turns out that only one of them is an actual solution, and it's that one right there. So the 25th percentile of this distribution is the square root of 1 minus the square root of 3 over 2. And so here I have the graphical representation of what we're talking about. And so again, I've drawn a horizontal line through the desired, or at a height which is equal to the desired level of the percentile, in this case 0.25. And then I've drawn a vertical line that intersects the point of our solution. And we see that those 2 lines, the horizontal and the vertical line, intersect the CDF where they should. And so that confirms that our analytical solution is correct. Okay, so just to wrap up this example, to summarize, finding the set of all values satisfying the definition of being a median of the distribution of x. And we found that there's only one value, all right, the square root of 1 minus the square root of 1/2. And then finding the set of all values satisfying the definition of being a 25th percentile of the distribution of x. Again, we found that that the 25th percentile exists, and it's unique. There's only one value that satisfies the definition of being a 25th percentile, and that is the square root of 1 minus 1/2 times the square root of 3. So that wraps up this particular lecture video, looking at how to calculate percentiles for distributions of continuous random variables. And we see that because the random variables are continuous, the nature of the distribution is such that it's much easier to, I say easier, in order to find a particular percentile, it suffices to solve a single equation. We don't have to worry about showing that two conditions are satisfied. That is automatically done when we solve, if we can solve that equation that we're supposed to solve, that being the CDF evaluated at the particular percentile we're looking for being equal to the level of that percentile. If we can do that, then we know automatically, because of the continuity of the random variable, the nature of the distribution, we know that both of those conditions are going to be satisfied. And really, the situation where we had to, the fact that there are two conditions in the definition of the percentiles is made necessary by the discreteness of the random variables that we saw in the last lecture. All right, and so that's really what drives the need for having those two conditions stated explicitly and needing to be shown. But again, once we, if we're in the context of a continuous random variable, then the situation is somewhat simplified. Okay, so that wraps up this lecture video, and we will continue on with the next topic in the next lecture video. That next topic is going to be expectations of random variables.